As I said earlier, we always hypothesize about the population. That is why when we express the null or alternative research hypothesis in symbols, you see the population mean, or mu, in the notation. On the top of the slide, you see the notation for the null hypothesis, a capital H with a subscript of 0. And behind the colon, you see expressed in symbols population 1 minus population 2 equals 0. That is intended to communicate that it is hypothesized that there will be no difference between the two populations, that the treatment will have no effect. Below that, in symbols, the alternative or research hypothesis is expressed. The subscript of 1 after the H denotes that. That notation is intended to express that we predict that the difference between the two populations will not be 0. On the slide is the formula for the independent samples t-test. It has the same general structure as the single sample t-test in that in the numerator you compute the difference between two means, and in the denominator you compute the estimated standard error. For the independent samples t-test, however, you are seeking to see how the means of two independently composed groups of people differ as a result of a treatment you give them. This treatment can take many forms. It could be two teaching methods, like the example we discussed a few minutes ago, or different dosages of a drug medication, or it could be based on group characteristics, in that you could be comparing the difference between a group of males and a group of females. The two groups could also be formed so that one group is a control group and one group is an experimental group. If you're doing a two-tailed test based on a null hypothesis, it won't matter which mean is designated as M1 and which mean is designated as M2. However, if you're doing a one-tailed test, the treatment group will always be designated as M1. Then, on the bottom of the formula, you divide the estimated standard error into the number you generate in the numerator. However, as you will learn on the next few slides, we have more steps involved in computing the estimated standard error because we have two groups of scores to consider.